Hi, thanks for tuning in to our EDD Presents.
My name is Haider Ahsan.
I'm Alvaro Guerra.
My name is Daniel Kim.
And I'm Mohamed Makhlouf.
And we are redefining oral sustainability. So a little bit of project history and background. Plastic pollution is a global crisis that really affects much of our world's ecosystem and the marine life, the local Gulf, and just the wildlife in general. Annually, 1 billion toothbrushes are thrown away each year, and each take around 1,000 years to decompose. In addition to this negative environmental factor, these plastic toothbrushes don't really address soft and hard oral tissue care to an advanced extent. Plastic toothbrushes pose a problem to waste, and this research relates new methods and materials that may be used for producing efficient, recyclable, and renewable toothbrushes. So justifications. Why is this a problem? So this is our problem statement. According to a 2020 British Dental Journal in London, the negative environmental impact of electric toothbrushes is 1,100% greater than bamboo toothbrushes. This disparity can be attributed to greater transportation costs, just resources that are used during its production. So this is our first justification, attack plan environmental. So this research paper basically goes over the ecological impact of various toothbrushes. We chose this paper as a justification as people consume 500 plus toothbrushes in their lifetime, and it's really important to understand the effect that consumerism has on our planet. Justification 2, attack plan health. This was a random controlled study, trial of adolescents regarding the effects of manual toothbrushes versus power toothbrushes. Obviously, electric toothbrushes did more, and really just kind of just shows the limitations of manual toothbrushes on our health. Justification 3, attack plan technical. This pretty much shows that conventional toothbrushes, they don't really address concerns mechanically that toothbrushes generally do, like lesions on the gums, etc. Justification 4, attack plan economical. This was an article talking about the amount of money that we spend on toothbrushes annually. And I have a couple more stats later, but pretty much just knowing that there's a large amount of money that's being funneled into this that could be used for longer, sustainable, long-term toothbrushes. 1 billion toothbrushes are thrown away in just the US annually. 50 million pounds of toothbrushes are added annually to landfills in the US. 310 is how many times more lethal nylon is compared to CO2. Nylon is used in the bristles of toothbrushes and even in the handles sometimes. And 4.4 billion is the total value of purchases of toothbrushes globally in just 2018. And this is expected to rise sharply with population.
Okay, so this is the attack plan diagram and how we plan on approaching the problem. So we have 4 criteria for redesigning the toothbrush, which is functionality, oral health, sustainability, and cost. Basically, the toothbrush has to work. It has to clean your teeth effectively. It has to be eco-friendly. It has to be a low cost to manufacture. So our expert intervention, we contacted Brett Duane. He's the associate professor in dental public health at Trinity College in Dublin, and he focuses on sustainable oral health services. And he really guided us throughout this process and showed us that in regards to our design matrix, that the categories must be universally understood because that would help us develop our project. So for our similar solution evaluation metric, in general, we got 8 different designs of toothbrushes and rated them based on different criteria, such as eco-friendliness, durability, cost, gum friendliness, cleaning effectiveness, and bristle variety. And the scores are very varied, actually. For the mind map, this is the direction we want to take our toothbrush and what criteria we want to achieve. So it has to be economically friendly. It has to be like low cost. Material has to be cheap. In regards to technicalities, it has to clean your teeth well. It has to be cheap, disposable. It has to have soft bristles for gum health. Environmentally, it has to be eco-friendly, and the design obviously has to look aesthetically pleasing. For the design matrix of the head, we basically brainstormed solutions, and we found that having a replaceable head would basically be a must for our toothbrush design because that would cut off a lot of plastic pollution compared to plastic toothbrushes. And we also decided on miswak was probably the best material to use. And that's seen here. We were deciding whether to use miswak or hemp and bamboo. And just because, as you see, there's a lot more benefits to miswak, especially in regards to dental health. and their recyclability and eco-friendliness of it, and a recyclability of it, that we decided to use Miswak for our toothbrushes bristles. And for the design matrix of the handle, it was a similar story as before. We basically wanted to see what the handle should be made out of. And we basically decided that it would be aluminum because we found that it was light, it was cheap, it was durable, easy to transport, and it's 100% recyclable. And an interesting fact is that 70% of aluminum ever produced in the United States is still in use. And we compared it to plant-based plastics, but we decided to use aluminum. So in general, our project solution summary is we made a cheap toothbrush with a disposable, environmentally friendly head and a aesthetically pleasing handle and body. The Miswak bristles provide effective cleaning and are low cost, and the soft bristles also prevent oral injury and provide the effect of a toothbrush of cleaning your teeth.
So these are the design criteria categories. The environmentally friendly, a very affordable price, ergonomically and aesthetically pleasing, easy to produce, very standardized, and very durable. So the first design category is environmentally friendly, where we replace the bristles with Miswak, and this improves the recyclability of the bristles. So next is cost. The upfront cost is no higher than $5, and the Miswak maintenance is lower than $15. The aluminum body is less than or no more than 50 cents per toothbrush. So the ergonomics and aesthetics, we've designed this product to be sleek and aesthetically pleasing for the consumer while maintaining its functionality. We've designed this product to also be separable from the bristles and handles, and so that it's recycled efficiently. As noted before, this product is very standardized, so this makes it easier for wholesale retailers to provide low rates for aluminum and Miswak manufacturing. The form and durability of our toothbrush, the durability of the handle lasts a minimum of 3 years, and the Miswak usually lasts from 1 to 3 months. So for our solution justification, economically, we've designed a very cheap alternative compared to nylon toothbrushes and maintained its environmentally friendliness. In addition, the Miswak implementation is easy and easily replaceable. And the Miswak bristles themselves have many medical benefits. While maintaining its functionality, this provides many health benefits for the user. So the price, as previously mentioned, does not exceed more than $5. We've tested the durability through online stress analysis and tensile strength simulations, and this has all been maintained with its environmentally friendliness. For the parameters for our solution, we've researched into the gingival index, plaque index, and oral hygiene index, and to be within regulations of those. We've also provided a parameter for safety. We've had a high thermal threshold for safety, and also set a maximum weight of less than 1 kilogram for in case of injury. For our product, we decided to go with aluminum 5052 due to its high stress resistance. Seen from this graph, when under very high strain, it is able to resist, and it has a very high stress resistance. And so for this reason, we've gone with this aluminum variant. From this table, we can see that thermal conductivity of the aluminum 5052 is very high. And so for this reason, essentially, we've decided to go with this because of its durability.
Okay, so let's move on to modeling, which is where we actually build the toothbrush. So to start off our modeling, we approached it in many different ways. First, we threw our ideas down, and each of us took turns designing a toothbrush and trying to incorporate everything that we thought of into our design. Here's our napkin sketch. This is the first design that we adopted, and this was the first design that we went about creating. We ended up scrapping this design later because of some limitations that might have not been addressed or some concerns. And we ended up approaching a design where you end up inserting the Miswak bristles instead of the entire stick, and using some sort of slider mechanism to lock them in place. Here you see some of our pattern drawings. This is where we measured the surface area that we would need for our aluminum. And we moved on to the illustration drawing, which is where we designed the toothbrush on paper, and we converted that into a 3D model, which we'll show So here's another drawing of the toothbrush design that we're adopting. It has a slider mechanism with a hole where you insert the miswak, and the handle is a perfect fit for the slider. And so we sent these models on a survey, and we asked people regarding functionality, aesthetics, costs, and 2 other categories. And as you can see, for these first 3 categories, the responses are generally really good. Most people tend to side with the pretty positive in functionality and aesthetics, and in cost, most of them were pretty positive because the price is really low. For handle durability, many people were positive in that area because it's made out of aluminum and it generally doesn't wear out. But for bristle durability, it was a little bit mixed, and it's partially our fault because we didn't explain it properly in the survey. Then we have the diagrammatic drawing. This is where we tell people how to use the miswak properly so that they do not misunderstand it and give a lower rating as seen in the survey. And then here's the 3D drawing, which is when we designed it. You can see the handle and the bristle holder on the left, and on the right is just the bristle holder by itself. Here's the orthographic drawing. This is the bristle holder without the handle. You can see the dimensions and constraints of each segment of the handle. And then here's the bristle holder. You can also see the dimensions of the bristle holder, and all the units are in inches. This is the final of our model with all the colors added. You can see it has a sleek design, and the reflection from the aluminum really helps to make it more aesthetically pleasing. Here's the bristle design. It's made out of miswak tied with a hemp twine, which is bound with starch-based glue. Every single material that we use here is 100% environmentally sustainable. And if it is littered, as many people would do, it will not cause any harm to the environment because it's made out of materials that come from the environment directly. And it doesn't ruin the durability of the design. And so we send our ideas and our models to our expert, Nancy Burkhart, which she is an adjunct professor at Texas A&M in the College of Dentistry. And she has extensive research in commercial toothbrush. And she told us that there were some bacterial concerns with the handle and the miswak design and how it's might be hard to clean. And she didn't know how long the bristles would last. And that was partially our fault with miscommunication regarding not just the bristle durability and the mechanical functions. And so she guided us into presenting these ideas more accurately, and we implemented that into our presentation. Here's a quick rundown of the material list for the toothbrush handle and the bristle pincher. We're using aluminum 5052, which generally is around $0.11 per pound. For the miswak bristle, it's mainly made out of miswak wood. It's bound with hemp twine and starch-based glue.
So this is about testing, and we tested if our design is actually viable. Because of a lack of time and the COVID-19 pandemic, we were not able to make a full model like we wanted to because we had no access to like 3D printers or any engineering equipment. So instead, what we did is we tested using a simplified model of the mechanical functions of the toothbrush. So for the price, the cost of all materials were added up and were under $5, which is good. And while this is an estimation, the boundaries are at their reasonable maximum, short of our set price. And for environmental sustainability, all materials were, as said before, 100% environmentally friendly and or 100% recyclable. And further testing would include research on manufacturing and transportation carbon impact. Cleaning efficacy. Although we researched the benefits of miswak, future testing of our design of bristles, including brushing trials, graded on the plaque index and oral hygiene index is required. And all materials are safe for consumer use so long as they stay in the respective usage fields. Bacterial concerns are noted, and although the parts are made for ease in cleaning, further testing on the hygienic value of the aluminum design is needed. For durability, the miswak bristles' lifespan is important to viability of the product as seen before. That was a major concern. And we decided to conduct a small trial regarding the material's properties when exposed to long or medium-term wear and humid environments. So one group member used a miswak stick, and the miswak stick was not cut during the testing period, which is 2 months. It was kept in the bathroom, as most people would use for the product. And the miswak was used every day, 2 times a day. So this is basically a picture of the before and after. You can see that after 2 months of brushing, there's actually not a major structural change, at least in the miswak, and it's still retains its original properties, which just speaks about how effective it is, and it's actually relatively durable.
And so, as mentioned, as you see from the experiments that we did, the mesowag bristles are indeed very durable, and they show barely any signs of deteriorating after 2 months of usage, unlike conventional nylon bristles. Mesowag also helps to revitalize your mouth, and it gives you a pleasant breath because it's naturally eliminating bacteria that grows in your mouth. And it's extremely convenient because it doesn't require the usage of toothpaste, and it's really easy to use. And because it's antibacterial, it does not need to be cleaned or washed. In fact, not once in the 2-month period that we were testing it was it washed.
So our conclusions and recommendations, our design philosophy follows that when economic and environmental interests align, the world moves forward. As a whole, our product builds upon the efficacy of regular toothbrushes with the stronger oral benefit of mesowag, as well as surpasses current generation eco-friendly toothbrushes and material costs. The design makes very few concessions regarding its goal and sustainability. Further concerns regarding future modifications of the toothbrush include maybe consulting a microbiologist on the possible biohazards on the aluminum and hemp string. Manufacturing and distribution methods must also be addressed and taken into account regarding the cost, both environmentally and economically. That's one of the fields we could expand on. We'd like to thank Mr. Valdez, Mr. Coulson, Dr. Brett Duane from Ireland, and Dr. Nancy Burkhart. Thank you for tuning in to our EDD Presents.